Okay, so in this in this video, we're going to talk about if two events are independent or not independent, and then we're going to use this information to understand the multiplication law. Okay, so let's go off of our example with officers getting promoted or not, and whether they are men or women. So we know that the probability of promotion is equal to 0.27, right? For men or women, doesn't matter. We're just looking at the probability of promotion is 0.27. We also calculated the conditional probability, so the probability of promotion given an officer is male or female is 0.30 and 0.15 respectively. So the fact that the probability of promotion changes conditional, so it depends on something else, tells us that these events, right, they are independent, or they are not independent, excuse me, they are dependent, right? So the probability of something, right, the probability of promotion, it depends on whether the officer is male or female. So if it depends on something, we cannot say that they're independent, right? They're dependent, so they are not independent. I know that gets confusing because it's independent, not independent. It gets a little bit confusing, but let's just say that one more time, right? The fact that the probability of promotion does depend on whether you are male or female, this means these events, right, are dependent. That is, they are not independent. So there's actually an equation for solving whether or not events are independent. So they are independent if the probability of A given B equals A. Probability of A, excuse me, right? And that makes sense, right? Because if you have a probability of something and then you say, hey, what's the probability of A given something else? Well, it shouldn't change. They should be the same. So this is where this equation comes from, and it's just what we observed, right? We found that these two equations, right, probability of A and the probability of A given M, they're not the same, right? What happens when they are the same? They're independent. But they weren't the same, so therefore they are not independent. So I hope that's making sense. If not, stop the video, rewatch it. Just make sure that you understand the difference between those because it affects what we're going to talk about next, the multiplication law or the multiplicative law. So we already talked about the addition law. It's used to compute the probability of the union of two events. Now the multiplication law is to compute the probability of the intersection of two events. So let's just look at the next slide here just to make sure that this makes sense. Right, we already talked about the union of events, right? That's the probability of A or B happening. Right, we already learned how to calculate that. Well, with the multiplication law, we're looking at the probability of A and B happening, right? It's this intersection. Right here, this color in blue. So we already learned about the addition law. We're learning now about the multiplication law. It's about the intersection. What is the probability of A and B happening? Well, here's the equation for it. It's the probability of B multiplied by the probability of A given B. Where does this come from? Well, if we go back to this last slide, the last thing I wrote is the multiplication law is based on the definition of conditional probability. So what is the conditional probability? We already learned about this, remember? What is the probability of A given B? It's equal to the joint probability divided by the marginal probability. Well, notice what's the joint probability? Probability of A given, A and B, right? What's the multiplication law? Probability of A and B. That's what we're interested in. So why not just solve for that? Well, that's what we can do. We can solve for it and get the probability of B times by the conditional probability, the probability of A given B, is equal to the joint probability. So that's where that equation comes from, right? The joint probability is equal to the conditional probability times by the marginal probability. So that's where that equation comes from. So I'm going to throw a curveball at you. The multiplication law for independent events is a little different. It's just the probability of A times by the probability of B. Why? Well, let's look at this slide and figure this out, right? So these are the two equations I've given you for the multiplication law. The probability of A and B is equal to the conditional times by the marginal probabilities. That was the first one I gave you. Then I threw the curveball at you and said, here's the equation, the multiplication law for independent events. Well, let's figure out what's the same, what's different. This part is the same, right, what we're solving for. We also notice that the probability of B is in both equations. However, the probability of A and the probability of A given B are different. But remember at the beginning of the video I told you we're going to talk about independent events, and they're important for the multiplication law. Well, we know if events are independent, the probability of A given B is equal to the probability of A, right? The probability of A should never change no matter what, right? So whatever the probability of A given B is, it shouldn't affect anything, so these two should be the same. Therefore, we can take this equation and see how this value is the probability of A given B, right? We know it's equal to the probability of A, so we can actually substitute probability of A for the probability of A given B to get, right, the probability of A times by, we're going to substitute the probability of A. So we just get the probability of A times by probability of B. You can reverse the order, that's okay. So does that make sense where that came from? So basically that's the multiplication rule for independent events, right? We have that, and then just the multiplication law. So that should make sense. I hope that makes sense. What I want you to do is I want you to solve this problem because I think it touches on important ideas. One, the difference between mutually exclusive and independent events. Sometimes we confuse those or don't really understand the difference between them. Also, sometimes I think with these equations, I'm throwing a lot of them at you, and I think it's important that just because you see an equation, don't just start plugging in values. Don't just start plugging in numbers to solve for the equation. Think about what you're doing. So take a minute, solve this, and in the next video I'll show you the solution to this problem.